Hello, welcome to our first video for section 1.4. We're going to go over some concepts about slope, what it has to do with real life stuff, and some vocabulary, and one quick example here. So first, the term rate in mathematics means this sort of specific thing. It means a ratio. Remember, is just another word for a fraction. So a rate is a fraction where the top and bottom of the fraction have different units. So here's a couple examples of rates. So if you're at a gas station and you buy 4 gallons of gas, it might cost $12. So if the units of the 12 is dollars, the units of the 4 is gallons of gasoline. So those are different units here. So if you put them in a fraction, you can write it as 12 divided by 4. 12 divided by 4 comes out to be 3. And you just take the units from the top and the units from the bottom, and that becomes the units of the result. We call that dollars per gallon. Rates in general are always going to have units that are like units per other unit. The whole thing together makes up the units of the ratio, of the rate. And a rate can be written in a lot of different ways. And in this case, if you get $30, if you spend $30 for 10 gallons of gasoline, or if you only buy 1 gallon of gasoline, you'll spend $3. All of these rates are equal. It's the same rate. It's $3 per gallon of gasoline. So that's a rate. Here's another rate. If you are comparing miles and hours, like if you're driving in a car, you might go 70 miles in 2 hours. That is actually the same rate as 140 miles in 4 hours. And in each one of those hours, you would have gone 35 miles. You can check that when you divide 70 over 2, you get 35. 140 divided by 4 is also 35. And so usually you just write that as 35 miles per hour. And anything like that is a rate. Now, a lot of the time, the most important kinds of rates that we're going to be looking at is rates of change, where the top and bottom of the fraction represent changes in quantities. This is an example of a rate of change here, probably. When you say 70 miles divided by 2 hours, that 70 represents a change in your distance. Like maybe you started off 100 miles from Albuquerque, and then you drove 2 hours, and then you were 170 miles from Albuquerque. So that's a change of 70 miles. So that represents a rate of change. Let's look at an example of that, where Gregor is driving across Montana. At 1 p.m., his trip odometer reads 189 miles, and at 4 p.m. it reads 360 miles. Calculate Gregor's average speed as a rate of change. Okay, so what we want to find is the rate where we look at the fraction that results from the change in distance divided by a change in time. Just like before, distance divided by time gives you an average speed. So now we're going to use a variable for this, a special symbol for change. We're going to use the Greek letter capital delta. You can read this as just delta. It's the way the ancient Greeks and modern Greeks spell the letter D, capital D. And this is used because D is short for difference, and a difference is how you calculate a change in something. So anyways, whenever you see this, read it as the change in, how much something changes. So with this example, you could write this as the change in D. I'm going to let D be distance here. divided by the change in t, where t stands for time in this case. And let's see, how can we calculate the change in the distance and the change in the time? Well, the change in the distance is going to be how far he went. The difference between his current odometer and where it started at. So if you went from 189 miles to 360 miles, the change in that is what you get when you subtract those. And the change in time is going to be how much time passed between 1 p.m. and 4 p.m. So that's going to be from 1 p.m. to 4 p.m. It's 3 hours. You can get that by doing 4 minus 1. And then we can subtract these and simplify it, which results in 171 miles divided by 3 hours. And if you want to know what is his average speed in terms of miles per hour, you can divide those and you'll get 57 miles per hour. And that is a rate of change because it compares the change in his distance divided by the change in his time. Now let's look at what this has to do with a graph that where we're going to make the t-axis here be horizontal and the d-axis be vertical. If we just plot these 2 points and look at the line that connects those 2 points, I just want to see where do the delta d and delta t show up on this graph, and how does that give you this rate of change? Well, first of all, when we say delta t, the change in the time, is 4 minus 1 hours. Well, what happens when you take this 4 hours and you subtract 1 from it? It's like 4 minus 1. It gets you the distance between these points here. So horizontal distance from this x-coordinate 1 to this x-coordinate of 4, as you can see, is 3. And that 3 represents 3 hours here. And you could also draw it here if you want as that distance like so. And that 3, it's the same 3 here. That's what we're calling the delta t. And likewise, the change in the distance is this vertical distance between these points, because this y-coordinate there is 360, and if you do 360 minus 189, you get that distance between them, that vertical distance there, which is 360 minus 189 was at 171 miles. And that you could also represent it over here as the delta d. So when you take that vertical distance divided by the horizontal distance, you remember from Math 115 that represents the slope of this line. So in other words, the change in d divided by the change in t is the slope.